So let's take a look at some of the graphs of reciprocal functions. As we learned yesterday, y equals tangent has a cosine in the denominator. So we had vertical asymptotes wherever cosine 0. Let's continue with that notion and graph y equals secant x. Well, y equals secant x is the reciprocal of y equals cosine x. So these graphs are the same thing, which means wherever cosine 0, we're going to have an asymptote there. Well, we can figure out where cosine 0 is from the unit circle, or we could use its graph to determine where cosine is 0. And that's the way I'm going to do it. I'm going to use the graph of cosine to see where is cosine 0. So let's graph cosine from 0 to 2 pi. But really, ultimately, what we're trying to do is graph y equals secant x by using the graph of cosine. So let's graph from 0 to 2 pi. Dotted line there. Sorry about that. There we go. So we're going to graph from 0 to 2 pi y equals cosine x, which should help us graph y equals secant x. Okay, so if we were to graph y equals cosine x, then we could easily identify where cosine is 0 and then put our vertical asymptotes in there. So cosine has an amplitude of 1, and cosine looks like a cup. Our cosine cycle looks something like this, in which these are our 5 ordered pairs. The period here is 2 pi, so we're going to end our first cycle at 2 pi. We're going to start it at 0, and we're going to start it up top. We're going to end it exactly where we started, wherever the period tells us. So halfway between these two reaches its minimum, halfway, minimum, and then halfway it crosses its axis. Halfway it crosses its axis. So this is the graph of cosine. So now we can see that cosine is 0 at pi over 2 and at 3 pi over 2. So that's where we're going to put our asymptotes, because that's where cosine is 0, which means we would have a 0 in the denominator. So that's telling us do not cross here with the graphs. So now this is what the graph of secant is going to look like. If you think about what a reciprocal is doing, if you take the reciprocal of a fraction, 1/2 for example, well, if the cosine is 1/2, then secant is 2. If the cosine is 1, then secant is 1. So what it's doing is it's making all of your values larger or equal to. So here's the graph of secant. There it is. If we get rid of the blue graph, which is cosine, now we have the graph of secant. Okay? Now let's graph cosecant the same way, but we're going to graph from -2 pi to 2 pi. So let's graph y equals cosecant x from -2 pi to 2 pi. Again, I'm going to graph sine first. That'll help me with the graph of secant. Okay, so I have my axis set up. I'm going to graph y equals sine x, which does nothing other than help me find the values for cosecant. So if I were to graph y equals sine x, that has a period of 2 pi and an amplitude of 1. And a sine cycle looks like this. And here are our 5 ordered pairs. So every distance of 2 pi will complete an entire sine cycle. So sine starts on a line, and we're going to end it exactly where we started it, every distance of whatever the period tells you. Okay, halfway it crosses the axis, halfway it reaches its max, and halfway it reaches its min. So here's one cycle. Let's graph in the other direction now. So now we can see our pattern. We're going to work in reverse now. 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1. So that's the order we're going to go in. As soon as you have the first 3 order pairs, you really have the rest of them. So let's see, negative pi over 2 will be -1, negative pi will be 0, negative 3 pi over 2 will be +1, and then 2 pi will be 0 again. So here's our graph of y equals sine x from -2 pi to 2 pi. Now, the only reason we did this is to help us graph cosecant. Remember that y equals cosecant x is equivalent to y equals 1 over sine x. So wherever sine is 0, this fraction is undefined. So we're going to put a vertical asymptote in there. Now sine is 0 whenever it crosses the axis. So let's put in some asymptotes. Wherever it crosses the axis. Okay, and then what we'll do is just connect our graphs. So here is the graph of cosecant. It's that easy. So again, just to summarize, whether you're graphing secant or cosecant, it helps to graph the original function and then just make them reciprocals of each other, just make the graph touch and fit in each of those graphs between each of the asymptotes. And the asymptotes lie wherever the graph crosses the x-axis. So if you wanted to, you can get rid of this thing, but it's not necessary. But this is what the graph of cosecant looks like without the graph of sine on it. So it's easy to recognize that way. If you want to put it into your calculator, make sure you're in radian mode, obviously, and there's no cosecant button, but you can graph 1 over sine, and it'll help you differentiate.